Okay. Hello, everyone. Thanks for having me. Uh, Before I start, when Jose invited me to the seminar, he said, "Hey, Batu, would you like to would you please come and talk about something that's exciting for you in the data science, and like something that you have been working?" And I said, "Yeah, gladly." And uh, like a month ago or so, I decided maybe this title is a proper thing to talk about because you know what? Like this is the question. This like I'm gonna form it as a question. This is one question that I keep getting from all of our data science students, right? Like, what is it to be? Like, what is changing? What should we be careful about, and etc. It might sound like the title might sound like I converted something exciting into something terrifying, but I can promise by the end it is not going to be terrifying. So here we go. And I would like to start with a personal anecdote, right? So I would like to take you back 12 years ago. And again, this is not a lecture, right? So this is 2014. This is from my PhD work. And at the time, I was working on keyword spotting. Keyword spotting, I was trying to find a way to find a distance metric for the problem, and at the same time do something clustering at the same time. And I found this modeled this asymmetric Siamese neural network, and I hand driven all of the gradients, like the training were working great. So on the right hand side, you see it was programmed in C++, right? And I had taken the deep learning courses like the quarter before I was doing this work, and I knew how to calculate the back propagation, like etc. I did, and I programmed it. Okay, so far so good. But then the following year, summer of following year, there came many. So this is me, what you see on the screen. It looks like I look victorious, but not. Like I will show you in a second. Next year, all of the autograph engines came, right? So like the TensorFlow, the Keras hadn't been there yet. PyTorch was gonna come in 2017. Theano has been there, but they are not there. But long story short, so this is me figuring out how to run TensorFlow, how to program the same thing in TensorFlow such that it does the automatic gradient calculation by itself. So I felt like like you look at my smile. It's not actually like super victorious. It's like happy and not happy at the same time. So because the reason is on the left hand side, this is my Siamese neural network back propagation, and I was like so proud of myself, like being like able to do this. And then so it was 700 lines of C++ code. Like I felt like, oh yeah, I learned it in the lecture and I implemented it. Yay, I'm super great. And then I figure, like, turns out the same thing could be implemented now, like 2014 to 15, with 20 lines of Python, like Keras, like this model dot fit. This thing was like made everything that I was doing, like I was feeling obsolete. So I felt like I am redundant. I felt like all the things that like I was gonna cry. Like I might even like shed a few tears or not. Like so I felt like so all of the skills that I thought I developed was for nothing. So like yeah, okay, start again. Like they just collapsed. Okay, so this is going to be relevant, and I would like to ask your opinion about my feelings, right? So, like here, and I'm gonna like you don't need to use your phones. I guess I have the link to here too. Please go ahead and vote. Like, let me know what you think. Was I right to believe that all of my skills, like doing how error back propagation works, and etc., like the lost that backward, I was doing the lost that backward was no longer a skill now that the Keras could do like auto differentiation? Or do you think I might use it in the future? So I'm gonna give it like maybe a minute, 2 minutes. It's not like um, and please let me know what you think would be the thing. Because I'm gonna get back to that because this is essential to to talk about like the generative AI, like what things are happening today. Okay, I'm getting a kind of a distribution of answers, which is good. I like people to comment on this. And like while you're at there, I'm not gonna keep you looking at the same question. I'm gonna go continue, but please, like if you're still opening and um, let me know what you think. Was it irrelevant? Was I right to feel sorry about myself or not? And then fast forward 12 years, you don't even need to code at all, right? On the left, so this is my cloud. I'm currently like jumping from Gen AI to Gen
Sorry.
AI.
Oh, sorry for interrupting you. That's okay.
Yes, no problem. Okay. So Gen AI to Gen AI. So like you can, and if you have not, you can do right now. Build me a transformer with the rotary positional embedding, train it on my client's data set located here in the client data. Like each and every one of these phrases were like something difficult at the time. And use cosine annealing with warm up, log to TensorBoard, and deploy it on the first available GPU. Let me see how the training, and voila, you see the training curves happening. So as they fast forward, as they continue, so like now this is the part that kind of terrifies us. And this is the part that for the current students or the students that are like learning things, like taking questions, like when we teach them like intricacies of how things work, makes them think that like makes you think like and us think that okay, like if I can do that, then why the previous one? So that's why we are kind of like this cat. Like this cat is happy, similar to my smile a moment ago. Like this is not 100% happy. Yeah, it's like magic. It's doing, but like, so what does it mean for me? Like if it is like if the data scientist job is becoming so easy, so what does it mean for me? So this is how we're feeling, and I'm going to speculate why are we feeling like this, right? So like happy but terrified at the same time. I feel like we're kind of you may feel like we're threatened and betrayed by our own kind because like it was us who were developing this generative AI, the modern AI models, and we would hope to get to automate some of the jobs, and we started from ourselves like let us automate ourselves, right? You may think so. And the part, and also like another opinion that come to mind is like yeah, we're one of the most expensive ones that could be replaced, right? So there are many jobs that could be replaced. So that's a little bit interesting, and like what does it mean for people, for us that are in the field of AI? But what does it really mean to be in the field of AI? Right? So like you may encounter two people who claim to be in the field of AI that don't even understand each other, right? So like at the center, you like we like in the core of AI, we learn how the modeling works, how optimization, etc. And some people take it to like applications, domain specific things. Some people approach it from the hardware training and etc. Field. So like there's not like it is like too vast and broad to like comment and compress, but I promised you that I was going to talk about like what skills matter now. Like how should I like position myself? Therefore, I'm gonna try to do myself. Therefore, I like this talk has to be opinionated, right? So it's almost like borderline speculation, but in order to make it less speculative as possible, I'm going to approach it how we approach our solutions, right? I'm going to approach estimating t plus one from the trajectory, right? So like today, x of t, this is the era, right? And we just established that the generative AI era, from the data science ML AI perspective, it's vast, right? So, and looking at this, like, how can we, like, this talk is not going to be talking about what is happening right now and what skills are going to be important at T plus one tomorrow. That would be just like the wizardry from Crystal Ball. So it would be like such a talk would be very speculative. Instead, what I'm gonna do is I'm gonna go back how like and I'm going to talk about like x 3 minus 3 t minus 3 t minus 2 etc. and like things have been changing. So like if we can actually go back to what has been happening and like how this trajectory continues, then we might actually have an idea, right? So it is very natural for you to think that what's been happening is like extraordinary right now. Yeah, it is extraordinary, but like in order for us to like take lessons for ourselves, first of all, I cannot say that I am the one who should like, yeah, I know everything. Like, let me listen to me now. Of course, I'm going to present to you from my own experience. So of course, I'm not going to start from Big Bang. I'm going to take you to x of t minus 8, right? So right after the last winter of AI. So at the time, the interesting models, like the things that worked, were basically a concatenation of two things. Like one thing was basically feature engineering for what you are doing. Like if you're in speech, you got your domain experts. If you're in NLP, you got your domain experts working on speech engineering. If you're in computer vision, at the time, like the people in AI, we were like differentiating ourselves like, oh yeah, I'm working on computer vision, I'm working speech, things like this, right? So it was a concatenation of feature engineering plus SVM. And SVM or some equally similar like logistic regression with some nonlinear kernels and etc. So what these solutions required some optimizations, some programming. And then in 2001 came libsvm. So the libsvm made your problem super simple. You would just go like svm-train. So suddenly, like a group of people who felt betrayed, like, oh, so I don't need to understand the convex duality, like the kernel tricks, like this kernel. I was programming all of these, and then libsvm came and I solve it all. So did they just disappear? I will keep doing this because, like, as we keep asking these questions, we will steer our minds to get our answers for ourselves and how to position ourselves and what is going to matter, right? So that decade was a great decade. And then, like starting 2007, 8, 9, scikit-learn became a thing. Scikit-learn made the cross-validation loops, like pre-processing at the time. Like no one need to calculate the PCA anymore. Like you would just do like PCA.fit, and you could do like these infrastructures super simple. But in my opinion, the biggest jump outside, like including maybe including the generative AI, maybe besides the generative AI, happened in 2010 to 14 with CUDA, QBLAS, QDNN. So like the researchers found a way to use graphical processing units, which only can which at the time was useful to have your video game faster, right? So like the play faster. But they found a way. Well, it is doing the matrix multiplication. I can do it. I can do the matrix multiplication in neural networks with convolution with GPUs, and so you don't need to understand the warp scheduling of the GPU processing. So you could do like just model that to CUDA, and you were able to just run a convolutional neural network, any kind of linear neural network on a GPU. So this was a big thing because that year, so by that year I mean 2012, there was the ImageNet. There has been ImageNet competitions, like I guess like 2 3 years prior, and so, like a team from Canada, Hinton's, Professor Hinton's students, Alex Kekevsky and Ilya Salzgeber, they won the AlexNet competition. They just like cut the error rate nearly in half. So the features that I was talking about, the SIFT features, Hog, Gabor, like all of the filters that I know having studied during my master's and early PhD times, like these are yeah important how to extract features and etc. They became irrelevant. So they became like the GPUs could take image, the raw image, and then you can actually uh, utilize backpropagation. That was a thing for like maybe 15, 20 years. It existed, but now it started being able to work, and you were able to get. But the lesson here that I want to emphasize, which is important, people who understood what was being replaced became the most valuable, right? So like they were not, oh my God, I was a very good computer vision scientist. All I could do was sift features and then SVM. They didn't just go home and then replace with the people who could do neural networks. It was them who became the new guys, right? And then 2012, we started using the pre-trained models. All of a sudden you could do, yeah, like as the backbone, ResNet 50 pre-train equal true because some people have trained the models, just use a pre-trained model as a backbone instead of using your SIFT hog features in your own problem. Maybe you're not working on ImageNet, maybe you're working on, let's say, face recognition, maybe you're working on cancer detection on MRI images. You could use those features as your new feature. So this made a big change. So there was a lot of expertise that became obsolete at the time. That was my painful thing. 2015 to 17, Autograd came. I used TensorFlow's logo here, but there were others. Theano like discontinued. Keras merged with TensorFlow. PyTorch became the best one. So like no longer you don't need to derive the gradients by hand, just like I did, right? So like it would be very unwise to like, oh no, I'm still gonna do like in case TensorFlow makes a mistake. It is unwise to do so, right? So you don't need to write the backprop code manually and etc. It was just lost that backward, open parenthesis, close parenthesis, and it was able to follow all of the uh, graph to calculate the backprop and learn, right? So all of a sudden, like the these people were replaced. I mean, not replaced. People were not replaced. Their jobs changed into doing something different then. 2000, like coming to like X minus two, like coming to near times. The Hugging Face made the transformers easily approachable. So like then you were able to make like instead of implementing transformers, reading from the paper, it was difficult, but you could just like model that from pretrained, and you could get the bird based on case, and they opened it, and you were able to use your transformers for several use cases. Then you were able to implement several interesting things which were not possible in the LSTM times. And finally, 2022 with OpenAI. And I was at a startup when this happened, and we were actually doing designing. I was consulting a startup. We were doing NLP pipelines, and then all of a sudden, like OpenAI, who has trained their very big model, like too big for us to have uh, on any GPU that we could purchase, right? So like think GPT-3 is 175 billion parameters. With 8-bit quantization, you're going to need a lot of GPUs to even just call it. But the APIs became like the client.chat that completions. You could run it. So like the entire startups, they were like they started being like, should I really be training my own thing? Because I had all these expertise, but like, should I be repping API? So that was a big thing. So the key point through this progress that I wanted you to like gain. So we went, I don't know, like 10 years, 15 years or so. So domain specific researchers, they did not lose. Like whoever was in the game, like all of a sudden, well, of course, I must say, like some people lost. Some people did lose who insisted on, no, 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 I have to be calculating my own derivatives with hand. Like those of them who insisted that they should be doing it, they got beaten up by those who like made the use of other things like these inventions. But those domain experts, researchers, right? Those that were in the game, they became the pioneers of the new era because around the time that the backpropagation became available, some researchers developed techniques to make the optimization better, right? So like they proposed methods like different versions of adaptive moment optimizers, right? So they came up with different methods of batch normalization, layer normalizations that made big changes, right? So if you stop thinking about like what's happening, you may stagnate. So today, in the generative AI, all of the boilerplate writing, right? So like, how do I do this? Do the loop in PyTorch? When do I need to do the zero grad? Like all of these things, or searching for Stack Overflow and etc. They're gone. And like, I can I go to like one thing I want to show you like what remains. So this is my Notion, right? So in Notion, and this is what remained. I wanted to like show you something, but I kept eliminating. So here I have some programming notes here, right? And now I'm going to delete all of these too. So I had all of my helpers to like, this is my notebook, right? How to like, I realized this is something that I have been calling a lot, like prevent the system sleep while running the code, caffeinate, minus I, Python, blah, 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 blah. And like Git helpers, like how to like, I need to keep in mind all of the how to use the Git, how to fetch, blah, blah, cloud computing. Now I I never visit this thing anymore. Like, and this continued. This had all the PyTorch related, programming related things. So I really don't need any of them. So like, I just open up, welcome Batu, just do what I want, right? So that's what today is. So doesn't mean that all of my expertise, my nice notebooks, like I color coded, etc., they're trash. No, I've been to there. It has already happened to me once. And the same thing is happening. So like it's a whole story. It's been happening, right? So like I would like you to see this is a very crowded slide. But the whole message is like the on the top cable, the algorithm model related advancements, and some cable, this bottom cable, the hardware related advancements happening at the same time. Sometimes when they match, just like the AlexNet time, they make a big difference, just like the flash attention and etc. Like all of these things. So, but the story is piggyback on the most advanced thing to advance your own thing. And also while doing so, try to invent a new thing. So that's the whole message. And you might feel like, oh no, 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 like all of these things that you presented, xt minus 8, 5, etc., they were different. Yeah, this one is big. yeah, this one is bigger. But the thing that I wanted to emphasize here, yeah, jump is bigger, but we're on the same exponential curve. So, like, what happened from yesterday to today? um I mean, not literally yesterday, but actually, like in a week, like a week ago, Codex came up. Like I've been playing with Codex. Now it's better than Cloud. Like things are happening faster and bigger. Yeah, but all I'm trying to say is that the jumps are getting bigger, but it's not a different thing. It's not like, oh, now the world is different. So now we need to position ourselves in a different way. I think we're in the same curve. It is the same exponential curve. The story is the same, and you're going to um, do the right thing if you like appreciate this is the case. So the truth is, our job didn't die. It just transformed, and the message here is that the mundane work is gonna disappear. So, and if you would like to, if I want to convince you to think about the accountants. 1980s, there was a skill to like very diligently like add large numbers with discipline and etc. With digital computers, no longer, right? But accounting changed. Accounting existed. Right now, what we're facing is the data science is now different. You don't need to like you don't we don't need to we shouldn't think that writing training loops from scratch, how to do blah blah, submitting cloud jobs is the thing, right? So like we it turns out, like my message here is that turns out it was the mundane work. It was the work that didn't really matter. Like we didn't have to do that. Like the data analysis that we did, all of these things, like how to like make nice visuals with Matplotlib. It turns out we could have spent our time in a better way. Another threatening, but in my opinion, not. Another bad feeling that you might get, well, if it is available to everyone, like if it is so easy to start, then then should I feel threatened, right? Like if it is like I have spent all of this time, like is my advantage disappearing? And my answer is no. Look at the Plato times. Like people had to get on ships to go to Athens from Ephesus to watch Plato, Aristoteles uh, explain their lecture on the sand, right? Like drawing things, objects on the sand. And then things were written and libraries existed. So, like for research, people were going to the libraries, getting the papers and reading them, doing the research. Now all of the papers are available to you, have been available to you. Like you could just like any paper, anything like available, have been available to you, just one click. So this became an advantage for everyone, and like the computational capacity is going to be an advantage for everyone. And it's your all I'm trying to say is that your advantage is not disappearing, right? So if everyone can generate models, then what is the advantage? The advantage is who understands what's happening underneath. For those of you who have already been, because I heard that the audience is like a mixed, right? Like those who have not started, those who have been practicing, those who are just looking into the things. For those of you who have been here, like it's easy to call lost dot backward, yeah, and the training starts. But all you're left with this black screen, right? Like you need to look at this and then understand from these numbers, what's happening? Like, is something overfitting and etc. And what I'm trying to say is that, like, if you have understanding the inner dynamics and mechanics of what's going on, your job is going to be simpler, right? So like okay, like in my understanding, the job is redefined as such. So previously, up until maybe 2 years ago, maybe last year too, like there were still people who were doing this, like cleaning the data, doing EDA, training model, optimize accuracy, writing the report. So that was a skill. That was something that you could request. Hey, can I have like, yeah, it's going to take a week or so, like, because I need to put my brain. Now you don't need to do that. So like now the skill, so the job, not the skill, the job is formed into understanding the system constraints. Are you going to like how much memory you need? Like it's because AI doesn't know what your systems are. Optimize for latency memory, be able to deploy such things, and like understand the system that the model lives in, right? So I would like to like give you some examples. Again, like we went through the research, like how and I just told you, like I did, now it's time for me to convince you that knowing the underlying dynamics, even if there's a technology invented that you don't need to use it, is going to help you. So, like, I would like to give you a few examples from my own industry and research experience over the past 10 years and like where it actually helped me. So like this story where I was almost about to like laugh and cry at the same time didn't turn out to be a bad experience. So 2017, I just graduated from PhD and I got my first consulting job. Like in a like sometimes like the way that you're gonna get your consulting jobs is not necessarily through knocking the doors, it's through like your networks, right? Like people I was talking to like a, a faculty. I was an assistant professor at my university, and I was talking to a faculty from physics department, and they got me like they this very big multi-billion dollar glass coating company required some help with an AI project. So their problem was the when they were like heating the glass coatings, um, the optical spectra change, meaning the color of the glass change. So like for skyscrapers is a bad thing. And it was a challenge for me to like talk to these people because they had no they had no terminology of AI, right? So like it was my first challenge to understand. And I understood, okay, like what could I train? And hey, can I get your data set? And they said, yeah, here, we have a giant data set that we accumulated. And believe me, like when people tell you, yeah, we have terabytes of data, giant data set, it doesn't necessarily mean the size of data set that we us data scientists value. So they actually had 380 samples, but like don't belittle that because each sample costs $20,000 to acquire and months of research. So like the from trial from trial and error methodologies. So yeah, I took it and I try to find a way to incorporate some part of the nature such that nature of the physical process, and I was able to make it happen. But not that this is past the TensorFlow of time, and I incorporated something that I used before my graduation times, and like the money that I got from them was like more than what I could make in like 2 years. So like, and it was only 380 samples to build it. So that was like that was it. That was the moment that I felt, okay. I started feeling maybe they are not going to anywhere. The problem, and then I joined 2019 ADI. But this time for my own problem, keyword spotting. But they knew that I was a keyword working for keyword spotting. But the challenge were they said like, hey, do your distance metric learning, but this is on an edge device, therefore it's quantized. It says to be this and that, and we would like to register new keywords like on the spot. So that was a different challenge. Like your old uh, model.fit doesn't work there, right? So like I used a great deal of my knowledge doing the back propagation that I developed during the back propagation. And then 4 years ago, I joined the University of Chicago MRI Research Center, and they said, okay, so like we have on the left, you see a MRI scan of a prostate, right? So it's very noisy. I don't see anything. I started seeing some things after 4 years working with them. I was their AI guy, and I said, "Hey, but you're the AI guy. So like, can you like this is looking at the same prostate? Can you do a super resolution just like the photography does the super resolution?" And I said, "Yeah." Like when someone says, "Can you?" Like my answer is yes, and I internally ask, "How?" And like I had recently read the paper Implicit Neural Representations, so INR here you see, and I try to convert, like try to find like ways to incorporate parts of like this MRI into doing this problem. But the challenge was that there's no labeled data. You didn't have the super resolution. But that was some work that I was like one of the most proud of. And it did work. It was like I created a super resolution image that was like we validated with many ways by scanning a QE in an MRI and etc. So this worked a lot. Again, recently for the MRI-RC, so they are like this is again an MR image, and MR image is giving you like this again prostate, and it's actually showing you the tissues like whatever you have, trying to show you whatever you have in your tissue, and like what we are trying to get if you have so much epithelium. I'm not like again like the nature like my goal is not to teach you how physics informed autoencoders work, how prostate cancer is detected. My whole message of this slide is to show you this. So the problem was they were trying to infer the underlying tissue composition from signals. So this was a least square solution problem, and it was not working. It was not noisy, and the noise was different. And I said, maybe we can make it into an autoencoder, and the decoder can be the physics rule that can backpropagate, and voila, it worked, and it got published. Like now, like the U Chicago is like the medical school is patenting it. It works like 10,000 times faster and like great. And again, like like this is post like this is even post like API era, right? So like, but what helped is deep understanding of the math, how models are formed, and etc. So what can be the next thing like while you're working? I can say that like I can recommend like four things. I'm not gonna like this is a boring slide again. Let me go to the fourth one. Long context attention because you're everyone is communicating with Gen AI right now, and as you keep continuing communicating with the same thing, you don't want it to slow down. Therefore, it's becoming it forgets. It's getting a little bit dumber and dumber, right? So the long context modeling is a thing, and that's something that everyone's working on right now. Again, reg like thinking about like how relevant queries are being picked up. Now you're Googling something. Many people are using ChatGPT or some Gen AI for web search. Like you need to be able to very quickly get the relevant documentations, but there are problems. Example given hubness, and there are some problems that I think that are like still important these days. But the message is not that. The message is my recommendation again. I want to emphasize my suggestions from an imperfect scientist, AI scientist. Like I by no means I am the guy to come here and speak. This is what I think, right? Again, like it is this lecture is by definition opinionated and speculative, but I try to make it less speculative as possible, but by going to the back, by going to the past. So my recommendation is like first thing is validating AI outputs, right? So like it's like always be doing on the AI, but like your job is not to keep approving, but like debugging AI generated code, validating like the statistical assumptions, looking at the hallucinations. So these are real skills that you may want to develop these days by working your assignments like that we are going to give you, like your own projects, right? Like working with generative AI and then following these like being a worker with it, right? So the second skill is the judgment. Generative AI is going to be very good at like writing the code, translating math, like all of these things, but it's not gonna know. Like for those of you who are already in the industry, they will know that it's not gonna know what is important for you, right? Like what problem matters, like what are the constraints. It's gonna say, "Oh, solved it, no problem. I just made it 32 bits." But you need to maybe do it like BF16 or TF16 model, and you're if you just miss it, you're just going to like prematurely be very happy and report your results to your superior and be embarrassed, right? So like you need to be like be on top of that. So I can reduce it to two things. So like don't be an auto approver because it is going to like it's going to be like very it's going to lure you to do that, right? Like you're going to open up any codex like Cloud Code. Yeah, would you like me to do? Yes, next, 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 next. And also the same thing, don't do manually what could be automated. So that takes me like again, my data scientists serenity prayer, grant me the serenity to accept the things that Gen AI can't solve, and the skill to use it for the right things, and the wisdom to tell the difference. So I think that's that's one of the skills. And lastly, I would like so this anyway. For anyone who has seen the social network movie, so talking about Facebook, um, so there was a scene that there was this concept of, oh yeah, I'm wired in, right? So I'm wired in. It means like in that movie and right now, like the data scientists, you might see some friends like that might be practicing their data scientist jobs. Like yeah, like I'm like focusing like writing code, like not communicating anything. Just I'm pushing my comments and I'm pulling it. Like I have my comments. Like why else do you need me? Never turning on their cameras, like not communicating with anything, just like messaging, texting, and etc. Right? They're just those who think that my work is going to speak for itself. I think like if you become this guy, you're going to look very much like Gen AI, and Gen AI is $200 per month. So Gen AI is going to feel cheaper than you. So don't be that guy. Please still be human. So like communicate, right? So I think this is I call it bonus skill, and I think that we will still want communication and taste. So like something, make sure that something differentiates you from generative AI. And like this is important. Generative AI is going to give you a lot of things. Like yeah, I can do this, especially at the times that you have no idea. The trick is which one is the good and like amongst the mayhem of like all of these extra things, right? So which ones to say no is the key because like you're gonna have the abundance of solutions. So you will still be in the room, right? So you're getting on the planes, pilots are flying the airplanes, but you know like that you wouldn't want to fly on a plane with no human pilots. Again, radiologists are like the diagnosis are being delivered to them by AI. Similarly, it's your thing, right? So like if you just give away everything to Gen AI, you are going to lose it, right? So back to my poll. Let me see how many people. I think most people said 88% said no, you might need this in the future. Like I guess like everyone was started the game in optimistic listening. But 12%, which I think 12% of the participants said, yeah, you would never use it. So this was a trick question, actually. There was no right answer. I wasn't right to feel unhappy, but I wasn't wrong either, right? So if I were to say, yeah, it's like I don't care. I'm gonna do my own hand skilled derivations because I got this. Like it took me 1 year. What do you mean I should not, I should automate it? I would have lost it, right? So skills are not going to disappear. They're going to move up, and you're going to try to see what you should move up. That said, I promised a 30-minute um, lecture or speech and try to leave the 30 minutes to questions, but I guess it took me more than 30 minutes. So yeah, I'm happy to answer any questions.
Hey, Batu, it's Greg.
Hi, Greg.
I'm going to throw out the first question, and students, you can put questions into the chat too, and we'll deal with them as you come in. But I just want to say, Batu, that in my career, the people who've been the most successful adapted to the changes rather than trying to compete with them.
Yeah.
And so adapting and leveraging the changes created an acceleration of careers rather, and the other side, trying to compete with it or trying to hang on to the old kind of created dinosaurs that eventually didn't make it. So that's been my experience with it. So I really appreciated your talk and a lot of good
Thank
stuff in
you.
there.
Thank you. Thank you.
We don't currently have any questions in the chat, Batu, but we do welcome folks to come on screen if they'd like to ask a question. I don't think we have to necessarily use the hand raise feature. So you're welcome to jump on because we still have a few minutes. All right. Well, I think we can accept the silence as everybody absorbing the information that we went through today. Um, Batu, great question. We got a question here, Batu. How should someone new break into the field?
Okay. Yeah. I think the answer to that, like, okay, I did not give an explicit answer, but I was trying to give an answer to this um, by actually learning the math behind it. Like my answer, like the vibe that I wanted to leave you, it was like when you're starting to your data science career, when you're taking the machine learning one, machine learning two, like deep learning basic methods. Don't think that they're not going to be useful, right? So like read your books, look at your formulas, implement them, and like don't be afraid of doing dirty work, right? So that's I think breaking into field, there's a learning curve, and then I think you should go through that curve to become someone prominent. There are some other questions of that. Oh, okay. Now the questions are coming in. How would you recommend we practice applying these new tools to a specific domain that we are interested in? Abdel. Okay, so my, if you're already in the field, and I like maybe chance, maybe life, the circumstances just led me to be in several different domains that and I see one of them here, Melissa Medved is joined our talk, like who's from the MRIRC, brilliant scientist. Like you end up seeing like I ended up like by luck learning the domain specific intricacies, right? So what I recommend for you to help you with your practice applying to the specific domains is talking to people, but reading papers about that domain also helps, right? So, like looking at relevant works that could have been done 5 years ago, maybe 10 years ago, maybe some books that are explaining what the problem is, and then and then go ahead and use your generative AI to solve that, approach this problem with the AI specific solution. Farouk has a question. How do you keep up with the speed of new AI tools coming every day? I follow YouTube, Reddit, like social media a lot, right? So I, I do, and Twitter also has these things. Some of the, by the way, I'm first of all, I must tell you, it is almost impossible. So like, you remember this big picture of like what it means to be the field of AI. There's no field of it, like you cannot follow everything, right? So you need to find yourself a sector, you need to find yourself a region, you need to find yourself something, right? And then like follow what has been applied and read. Sometimes more often than not, I value how many citations or like how many mentions like some of the codes and etc. get for representation learning for the field that I'm like most passionate in. There are great conferences, NeurIPS, ICLR, CBPR. It's very difficult to publish there, but it's being redefined too. If you look at every time that ICLR, CBPR, and NeurIPS are published, just look at what's hot, and then you can get that. Eugene has a question. Would it be necessary for a data scientist to still understand real process behind the code? For example, what each code mean, what each parameter mean, while LLM is coding in a complex, efficient way? My answer is yes, Eugene. And I can convince you like this. So if you're, let's say you're Python, right? You're mostly doing Python, and let it write something in PyTorch and Python language, and then look at the code that it is doing, and then be involved, approve 90% of the time, and then be proper what they are doing, and try to do something that's not amongst your skill set, right? Let's try to do something in Java, some animation, right? Open up Cloud Code or like whatever your favorite, and open up your thing in Java, and then ask it to do some animation, right? It is going to do it. It's going to feel fancy, and very soon, like, and ask it to like do some modifications. Hey, I want boxes jumping and turning green. Explain something, and then very soon you're going to feel like you're not in the game. You're not there. You're just like you are powerless. You are useless, and you cannot do much. You're going to feel very soon if you look at if you try to get it to do something um, that's not in your skill set, like web page design. Like I cannot assume. So that means if you want to be a data scientist in that domain, yes, you need to understand what it is doing, right? So like if it is if the large language model is coding complex in slash efficient way, it's actually teaching you the efficient way, right? So I would say yes. Clooney asked the question, are we going to be introduced to those tools incorporating GenAI that will help us with the day? And as Greg answered, yes, that's something that we do like. That's something that we actually care and design the courses as such. Abdel, so reading up on the specific domain, talking to people in the field and using GenAI to solve unique problems. Thanks, Abdel. Thank you, Abdel. Whoops. Okay, Rajiv. Will understanding the mathematical theory, model assumptions, and interpretation be the most resilient long run? I think it is the case because programming is becoming less of a skill, in my opinion. So, yeah, and like reading the theory, and if you are able to read the paper, and it means that you know the terminology, you know what is the important thing, what is not the important. Like you see that something should work, and you are going to be able to like particularly define it as such, right? So if you know the mathematical theory and like the science behind it, um, I think it is going to take you the farthest. I would agree with what Rajiv said. Martin says, going back to the first poll, I would like to put it as a spectrum. What would you say are the essential elements of the past to keep as a strong base of knowledge and what to let go or adapt as change? I'm curious about Greg's answer too. I find a balance between the understanding of the principle and then seeing how you can move beyond is helpful. This is done by attempting the past to a bit appreciate the speed and efficient today. Yeah, that's also like yeah, that's a great question, Martin. Um, Essential elements of the past. Again, like okay, if you have a hammer in your hand, all of the problems look like a nail to you, right? So that's that's I think my hammer is understanding how neural net like what's happening every part of the neural network, right? And what a neural network is doing. And I have always seen this as like understanding what a neural network, understanding when you need a layer norm, when you need some batch norm, when you would need what is an attention doing, and etc. Like these things, the function of them. So if I know like each and every one of the functions of them, like if they are like all some f of x, right, concatenated, I think that's the only thing. That's the general skill that you would want to maintain, in my opinion. Wang, I'm really interested
Hey,
in
hey, Batu.
hello.
Just a quick example that I just want to throw your way is grid search for hyperparameter tuning. I mean, it's wonderful, but I used to have to do all of that without that feature available.
Yeah.
And so how much, do we mess around with parameters to get a feel for what's going on, and how much do we just do grid search to get the optimal parameters? And I think that illustrates the balance between, yes, there are new capabilities that fully automate that stuff, but I still like to play with them.
Yeah.
And in the past, I didn't even have grid search. I had to actually mess with those hyperparameters and see
Yeah.
what's happening. Anyway, I just offer
Yeah.
that as an example of the tension between playing with it versus just using the fully automated option.
True, true. Yeah, now weights and biases. Maybe I should have put it there too. Like research, like hyperparameter optimization. There are tools that does for you, but you soon again you understand that like if you don't put any expertise, any like of your brain, like we at work we call it let's use our meat brains, right? Because the as opposed to the Gen AI electricity brain, if you don't put in anything we you're gonna see that this search of hyperparameters is gonna like, take you maybe a month or maybe 2 months, right? So, all right, the questions are like now coming in, and I don't know if we will be able to how much we will be able to cover in a minute. I don't know if we have a hard cutoff, Patrick.
Yeah, we typically do have a hard cutoff on this. What I would like folks to do is be able to reach out to you, Batu, if that's okay. Maybe you could
Yes.
leave them your U Chicago email address just in case there's any questions. We just want to thank you all so much again for coming out. Hopefully there was a lot to learn. I know that I will probably take the data scientist serenity prayer with me forward, as I think others should. So I hope that you all enjoyed, and please reach out to us with any questions related to the program or any of the future topics we'll cover. Have a good afternoon.